Hello, my name is Adam Keller, and I'm a developer advocate on the Container Services team here at AWS. In this session, we're going to explore the options available for running containers on AWS and the advantages they offer. Whether you're just beginning to learn Docker or you're an expert with Kubernetes and all things containers, join us to learn about the ways you can run your containers on AWS. We'll start off by talking about why companies move to containers, and then we're going to dive into the various services that support our customers' use cases for running them. Lastly, we'll provide some resources to help guide you as you navigate through the world of containers on AWS. Containers are all everyone seems to talk about these days, and container adoption is growing at a rapid pace. So let's talk about why. Containers provide a standard way to package your application's code, configurations, and dependencies into a single object or artifact. The artifact, otherwise known as a container image or a Docker image, provides a consistent experience from testing locally on your laptop to running in a production environment. This enables developers to iterate at a high velocity and offer the speed needed to scale to meet the demands of their applications. Aside from the speed and portability, the orchestration component has been greatly simplified with managed services such as Amazon ECS and Amazon EKS. By letting AWS handle the infrastructure and operational burden, customers are able to reduce the risk and focus on building business logic instead of the infrastructure. Lastly, by moving to a controlled and repeatable environment and embracing automation, we see product delivery velocity drastically increase while improving quality, stability, and security. Today we have hundreds of thousands of customers using containers on AWS to run their workloads. And as you can see, adoption is not limited to one industry, it spans across all verticals. Here's a high-level overview of some of the modern compute technologies available on AWS today. We start with AWS Lambda, which is a fully managed serverless offering where you simply provide your code and Lambda will run it on invocation. Very common to use Lambdas in event-based architectures. And then there's Amazon ECS and EKS, which are where you run your containers, as well as AWS App Runner, which is a fully managed way to run your code without even having to know what a container is or how to build a container image. And as we progress down, we go through the different layers of the stack. We talk about hosting, which we're going to dive into in just a moment, whether that's AWS Fargate or Amazon EC2. And then where you store your container images, which is Amazon ECR, which is a fully managed container registry service. And then we have all the different components and integration services like Amazon EventBridge, AWS Step Functions, and so on. And lastly, there is the third-party tooling, which is third-party vendors like Datadog, as well as open source tooling like Prometheus and Grafana. Earlier I mentioned Amazon ECS and Amazon EKS. These services orchestrate how your containers run, but you still need a compute layer for where your containers run. AWS gives you a range of integrated compute options for where that happens. You can choose the right tool for the job to get the right blend of cost, performance, and features. On both Amazon EKS and Amazon ECS, you have the option of running your containers on the following compute options. As I said, there's AWS Fargate, which is a serverless container compute engine where you only pay for the resources required to run your containers. This is suited for customers who don't want to worry about managing and patching servers, handling capacity planning and scaling of those instances, or figuring out how to isolate container workloads for security reasons. There's also an option to save costs and take advantage of Spot with Fargate on Amazon ECS. Then there's Amazon EC2, which offers an array of choice depending on the needs of the workload. This includes working with various processors such as ARM and x86, enhanced storage, as well as more performant networking instances that have GPUs, and so on. This is ideal for customers who want to manage or customize the underlying compute environment and host operating system. If you need to run at the edge or take advantage of 5G, we have local zones and wavelengths, which can support our customers and bring you even closer to your customers. And finally, for containers running in hybrid environments between their data centers and AWS, there's AWS Outposts, ECS Anywhere, which is available today, and EKS Anywhere, which is coming soon. One of the most common requests we hear from customers is help me decide which container service to use. We recommend that most teams begin by selecting a container solution that aligns to their application requirements or operational preferences. AWS customers have choice of fully managed container services, including Amazon Elastic Container Service, ECS, and Amazon Elastic Kubernetes Service, EKS. Both services support a broad array of compute options, have deep integration with other AWS services, as well as provide global scale and reliability you've come to expect with AWS. So let's dive right into them. We're going to start with talking about Amazon ECS. Amazon ECS is a fully managed container orchestration service that enables customers to run their most sensitive and mission-critical applications on AWS. When running containers in a real-world environment, generally there's the need to orchestrate the how and where the containers run. This is the job of Amazon ECS. I mentioned that it's fully managed, but what that means is that the control plane is fully managed. So when there are updates to the ECS control plane, you don't have to think about upgrading the control plane, rolling out updates. It's just inherently there as the service continues to update and progress, with no changes needed on your end. ECS has a robust scheduler that enables flexibility in how you run your applications. Whether that's as a long-running service or a one-time launch of many tasks, beyond that, there are advanced ways to schedule your containers using capacity providers, which further abstracts the management of the underlying compute. And with capacity providers, you can take advantage of cluster auto-scaling if you're using EC2 instances in your environment. This enables you to focus on your application and not the underlying infrastructure. When operating ECS, you use one API when talking to ECS or other AWS services. We've also built tight integrations with Elastic Load Balancing, automated registration of tasks with the load balancers. Amazon EFS for persistent storage in the container, automated logging and metrics with CloudWatch, as well as integration with Secrets Manager and SSM Parameter Store. You can extend and build on top of ECS APIs. For example, Jenkins has an ECS plugin that directly integrates with the ECS APIs to deploy your services. ECS is secure by default. You can choose to take advantage of AWS Fargate to run your tasks, so you don't have to think about managing the underlying virtual machines. Also, access to other AWS resources is scoped to the task level, so you can be as granular as you need on a per container basis rather than having to just grant permissions globally. As mentioned earlier, ECS customers can take advantage of AWS Fargate to run their containers, which enables you to simply focus on your application and what your application needs to scale. Lastly, we recently announced ECS Anywhere. With ECS Anywhere, you can run your ECS tasks on your own hosts in your own data centers, all while being able to take advantage of the fully managed control plane that comes with AWS. So when we think about what it takes to get your application from your laptop to a live production-ready experience, regardless of the technology you're using, generally we follow the same workflow. This is a develop, build, release, and operate. So you keep your code in version control, you automate the build process and then store your artifact, which is your container image, into a container registry or repository. From there, you need to deploy said image into your orchestrator, following the instructions of what your desired state is. How many tasks do I want running? How do I scale my containers to meet demand as it ebbs and flows? Finally, there's the day 2 operations of observability and monitoring your containers. There's a lot that goes into getting this right. And if this is not your day job, it can be quite a headache to get up and running. This is where the tools you choose to deploy your services and your tasks and containers are critical. So now, to accomplish everything we just said, there's quite a few ways one can do this to accomplish the desired state. ECS is compatible with a number of developer tools to help you get up and running. You can choose based on you or your team's preferences. So for those that prefer user interfaces, the management console is a great place to start. You can click through and configure each setting for your ECS deployments and visually observe their health through logs and metrics in CloudWatch. However, repeatability becomes a concern, and generally it's advised that when you need to reproduce environments, you take advantage of automation through infrastructure as code. So for users that prefer powerful simplicity through a command line interface, the AWS Copilot CLI lets you get up and running with production-ready environments in minutes. We'll talk about that in just a moment. For the most control and automation, users can define their ECS resources as infrastructure as code and deploy through the AWS Cloud Development Kit, which is otherwise known as the CDK. The CDK lets you define ECS services, clusters, and other AWS resources and configure them with a programming language such as Python, JavaScript, or Java, just to name a few of the supported languages. The CDK also provides higher-level patterns or constructs like a load-balanced Fargate service or a queue processing service that creates all of the resources behind the scenes with just a few lines of code. These are not mutually exclusive. You can use all of these together. So let's start by talking about the Copilot CLI. Copilot focuses on application-first abstractions and solves the problem of stitching together infrastructure for a production environment. Copilot provides AWS best practices out of the box for you. Copilot provides guided experiences to go from a Docker file to a production-ready ECS Fargate service within minutes. And all of these choices are written to a simple manifest file. This is where you can go and tweak the values for your application as needed. We also can set up a CI/CD pipeline with AWS Copilot that will automatically deploy your application to multiple environments like test, stage, and production. And we've also built in the day 2 component. So you'll hear me say day 2 a lot. And that's usually when we talk about what you deal with after you've deployed the containers to your environments. So we have operational commands built in to view metric alarms, logs, and tasks, or service level details, all in the same CLI tool. This ultimately enables customers to focus on their business logic and less on the boilerplate, and by leaving that to us. Next, I want to talk about the CDK just briefly. The AWS CDK is an open source software development framework to define your cloud application resources using familiar programming languages. It provides you with high-level components called constructs that pre-configure cloud resources with proven defaults, so you can build cloud applications without needing to be an expert. As I mentioned earlier, the CDK has these high-level abstractions, which are called constructs, built for Amazon ECS to build on common patterns. And in the slide here, you can see there's some examples. I have a queue processing service, Fargate service, as well as an application load balanced Fargate service. These are just a few lines of code, but the abstraction underneath actually compiles to Cloud Assembly, which equates to hundreds of lines of CloudFormation code. And finally, I want to touch on AWS App Runner, which we launched earlier this year. App Runner offers a fast and simple way to build, deploy, and run modern containerized web applications and APIs on AWS. It doesn't require developers to have any previous containers or infrastructure experience, and it's built on top of AWS Fargate. App Runner also ensures consistent application and API response times by reducing latency and eliminating cold starts. App Runner is built for web scale, so this means you're not going to outgrow the tool. It's going to be here to support you from day one to all the way down the road. So that was ECS and App Runner. Let's talk about Amazon EKS. Amazon Elastic Kubernetes Service, EKS, is a managed Kubernetes service that makes it easier for you to run your Kubernetes workloads on AWS and on premises. Amazon EKS helps you provide highly available and secure clusters and automates key tasks such as patching, node provisioning, and updates. EKS runs upstream Kubernetes and is certified Kubernetes conformant for a predictable experience. You can easily migrate any standard Kubernetes application to EKS without needing to refactor your code. So we're going to break down the journey of where we started with EKS when we released and the different phases we went through and where we're going to continually improve the service. So we're going to break it down in these different levels. So we'll start with where we started, which was the management of the control plane. Then we'll talk about how we've helped to manage the data plane. And then now the third phase where we talk about managing these operational add-ons. Managing. So Amazon EKS was born from customers telling us that managing a Kubernetes control plane required a lot of operational overhead and was taking engineers away from focusing on meaningful business value. EKS runs the Kubernetes control plane across 3 availability zones for high availability. So what does this mean? This means that there's 24/7 operation and maintenance of the control plane, automatic scaling of the control plane in response to increased load, which is usually from additional worker nodes that are connecting to the cluster, certificate rotation, and one-click version upgrades, along with much more. The beauty is that you don't need to worry about any of this. When you create a cluster, you get a Kubernetes endpoint and let EKS manage the complexity of the control plane. You get to take advantage of the operational best practices we've implemented based on learnings of managing hundreds of thousands of clusters at scale. As mentioned earlier, EKS runs upstream Kubernetes and is certified Kubernetes conformant for a predictable experience. Lastly, EKS has seamless integrations to work with AWS services for load balancing, monitoring, logging, security, and more. So that covers the first phase of when we released EKS, which was giving a highly available and performant experience for managing the cluster. Let's talk about the second phase, which is the control plane. The data plane. To run applications, customers use Amazon EKS to create and manage the nodes for their Kubernetes clusters. So when they're running their applications, previously to releasing EKS managed node groups, which we're going to talk about, customers had to understand how to configure multiple AWS services and stitch all the pieces together. This included EC2, auto-scaling groups, ensuring that you pick the right instance types, as well as ensuring that your EC2 instances connected to the cluster properly. Customers had to manually update these nodes to apply security fixes, or as well as adopting new Kubernetes releases and versions. Additionally, once the cluster is created, there was no centralized view for customers to see the provision infrastructure in their clusters. So customers needed to check a combination of services and logs and different AWS resources to kind of stitch everything together. Overall, this required a significant amount of time and energy for customers to gain both AWS and Kubernetes expertise to run their nodes in the data plane. With managed node groups, Amazon EKS lets you create, update, and scale, as well as terminate nodes for your cluster in a single click or command. These nodes can leverage EC2 spot instances as well to get reduced costs. Managed node groups run EC2 instances using the latest EKS optimized AMI, or you can bring custom AMIs in your AWS account while updates and terminations happen gracefully to drain nodes to ensure your applications stay available. EKS orchestrates rolling updates and node draining before terminations, again to ensure that application uptime is met. We launch nodes across multiple availability zones by default, just to give you that high availability, and each node group is tagged with automatic discovery when you run the Kubernetes cluster autoscaler. And we also monitor the configuration of your EC2 infrastructure. And you can check if everything is properly configured through the ECAS API and console. With these health checks, complex problems such as IP exhaustion are simple to diagnose. Managed nodes also work with tools like Datadog for monitoring. So now we talk about the next phase, the phase 3, if you will. And this is where we talk about supporting and managing the add-ons. But before we do, let's briefly talk about AWS Fargate on EKS. So just like we mentioned with Amazon ECS, Fargate is supported on EKS as well. And this enables customers to run tasks or pods in their Kubernetes applications using serverless compute. Fargate removes the need to provision and manage servers, and it lets you specify and pay for the resources per application and improves security through application isolation by design. And finally, we're at that phase 3, which I just mentioned, where we start to talk about managing the additional software that runs in your cluster. And this is where EKS add-ons come in. EKS add-ons provide automation to install and update operational software such as Core DNS, kubeproxy, and Amazon VPC CNI for customers' clusters. You enable it, you get one-click upgrades of these software, of this software out of the box and in your clusters. This allows customers to bootstrap their clusters that are ready to go with the software that they desire at launch. So we look forward to continuing to grow here, and you'll see a lot more with EKS add-ons in the future. So let's talk about tools for getting started with Amazon EKS. First, there's EKS CTL or EKS Control, whatever you want to call it. EKS Control is the official CLI for EKS. It's an open source tool for creating EKS clusters in minutes with a single command. The EKS Control command line utility provides the fastest and easiest way to create a new cluster with nodes for Amazon EKS. It also has GitOps enabled, so you can use GitOps in your workflows right away with EKS Control. And to create a cluster, it's as simple as EKS CTL create cluster. So I mentioned earlier the AWS Cloud Development Kit, or the CDK. Well, applications running on Kubernetes are composed of dozens of resources maintained through YAML files. As applications evolve and teams grow, these YAML files become harder to manage and larger. Building new applications requires writing boilerplate, copying code, and manual tweaks. Sharing best practices or making any updates involves manual changes and complex migrations. All of this YAML engineering takes time away from delivering value to your customers. And this is where CDK comes in. So when we say CDK, that's the abbreviation for the Cloud Development Kit for Kubernetes. CDK makes it easy to define Kubernetes applications using familiar programming languages, including Python and TypeScript. CDK includes tools that can be used to interact with any standard or custom Kubernetes object as a strongly typed class. Additionally, you can author higher level abstractions using the languages. IDEs, tools, and techniques you're familiar with, and share them through regular code libraries with your team, company, or the community. This simplifies defining them and maintaining applications for all Kubernetes users and builds on top of the Kubernetes declarative API approach while fundamentally respecting the capabilities and flexibility. So to conclude, customers today are building more quickly and efficiently than ever, in production, at scale, and around the globe. We have a full stack of services and technologies and tools for every workload, both specific to containers and to integrate with the breadth of AWS capabilities. And we have much more to come in the year ahead. Thank you for spending this time, and we really look forward to talking about, seeing what's ahead in the future. So there are some resources here if you want to get deeper into EKS, ECS, or AppRunner. We have 3 publicly available workshops at EKSworkshop.com, ECSworkshop.com, as well as AppRunnerworkshop.com. You can run these all on your own. They're self-paced workshops, and they go high level and very deep, depending on what your use case is. And lastly, there's Containers from the Couch, which is a regular show where the developer advocates from the container services team talk all things containers. So check us out on containersfromthecouch.com, and please do subscribe. And you've joined the AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS training and certification for containers and serverless. We offer online digital training that's available on demand, and you can go deeper with the 3-day instructor-led course, Running Containers on Amazon Elastic Kubernetes Service. You can also explore labs, white papers, and other technical resources by downloading the AWS ramp-up guides. For more information, visit aws.training/learning library and select containers or serverless domains. So that's it for me today. If you have any questions or you ever want to reach out to me, I'm on Twitter at RealAdamJKeller. And please do take the time at the end to fill out the survey. We always appreciate customer feedback. And I just want to thank you again for spending these 30 minutes with me, and happy deploying.